Hey, Michael Morris here in the Gorilla Shop with part 4 of how I machine a fidget spinner. Alright, so in the second operation we are turning something that looks like this into something that looks like this. So we are machining off everything that's above the top of this button. And as you can tell, we don't have much space to grab anything with right here. That's like 80 thousandths of an inch right there. Hardly anything to grab. So yeah, I had to get kind of creative with my fixturing. So let me show you what that looks like. This is the fixture palette that I use for operation 2 of the buttons. It's basically 2 3-jaw chucks screwed to an aluminum pallet. I can do 2 buttons at one time with this setup. So let's take a closer look at one of these chucks. There is a stainless steel rod that goes all the way through and is screwed down to this aluminum pallet. On the top of this, you can see there's a pocket that goes in, and then I have a grub screw screwed into that. The way I secure these buttons is I utilize the fact that I already have the threads on the back side of this button. So I use the threads to screw in the button all the way till it's seated. Give it a pretty good tight little twist there. What this does is it holds it down in the Z direction, so it's not going to come up or down. Because I have such a small space down here to grip it on a X and Y axis. So from here I tighten the jaws down, I squeeze the jaws into the bottom side of the button, and I don't really have to crank it down too much, just tighten it down pretty good. That secures this button in all directions, and there, like I say, there's not much I can grab onto, but there's enough to grip it in the X and Y, and the screw holds it down in the Z. It took me months, maybe even a year, to really land on this design. I tried a lot of different things. Without the screw down on the bottom, these buttons were shifting a little bit, sometimes popping completely out. On the softer metals, I was denting up the bottom of the button and really ruining the finish of it. Yeah, it would work sometimes on the titanium and the stainless steel buttons, but when it came to the softer metal, this was the only solution that I came up with. So now that that's secured in there, I'm going to probe and find out exactly where I need to start my tool path. So in this one, I actually set the probe to the top of that post, and then I go up 0.184 inches. In this case, I would go down because the probe stopped at about 0.35 inches. Let me take it to 184, and then I'll set it to 0 on my Z-axis. So there we have the Z-axis set. And then I want to find the boss center, and this is just a rough estimate. It's close enough for this first pass. After I knock off this lip here, then I reprobe it to find the true center, because I really don't trust this stock. So we're going to go around the perimeter of the button, find the center of the stock. Alright, and I do that for both buttons before I machine. Okay, so we are going to take off all of this stock that we used to hold the button down on the first operation. So this is a circular facing, I'm going to call it. Going to speed it up a little bit here. One step at a time, going closer and closer to the middle. There we go. And boom, there it is. Alright, all nice and smooth. And now we have something solid to probe the outside of this button. But first I'm going to make sure, before I use the probe, make sure there are no burrs around the top that probe can catch and give me a false reading. Because I need to get the boss center of this button. So we're going to probe it again. This is the actual profile of the button. I don't probe the stock when I flip it over, because I guarantee you it would be off by at least a little bit. So to stay safe, I probe it again. And then I actually face it down to what I need, which is going to be the actual top of the button. Fast forward it up a little bit here. And do another circular facing toolpath motion. Alright. And I have a little hitchhiker here. This is probably a stainless steel little splinter. Copper usually doesn't do that to me. But, you know, you pick them up here and there. Okay, so I'm going to spot drill, and then I'm going to drill down so that I can get this button ready for the ball end mill and make the dish. And before I do that, I'm going to cut some steps in the top of this button with this 1/4 inch end mill here. And the reason why I do that is so that I don't have to use the ball end mill as much to remove a bunch of material. So I try to remove as much as I can with the drill bit and this end mill here. And I also do the same thing for the outside so that I don't have to take as much off with the chamfer. This is called an adaptive toolpath. I'm getting rid of the bulk of the metal before I use the shaping tool. And this next machining move with the ball end mill makes the dish. And it's probably my favorite toolpath to watch. All the rest of them I usually step away and do something else for a little bit, but you get to this ball end mill, I usually watch it just because it's kind of cool. And so I'm not going to mess with the speed on this one. I'm just going to let you enjoy it. So every time it does a pass, it goes a little bit deeper. And it spirals around and down at the same time. And once I get it to the right depth, you'll see here in a minute, I'm going to start the cutter from the bottom, and I'm going to go up a couple of times. And each time the distance between the spirals are closer together, so that the finished result is as smooth as I can possibly get it with this cutter. So this one goes down to the bottom and works its way up. And you know, all of the machinists that I know that machine spinners do their buttons on a lathe, which looks a lot different than this, because the actual button spins while the lathe cutter cuts it. In this operation, the button stays still while the cutter spins. Alright, and you can see how smooth that is. Okay, so let's talk chamfering for a minute. This button has actually 3 chamfers going around this top curve right here. Have this large chamfer that happens right here. Have a micro chamfer that happens at the base of this chamfer. And then we have another micro chamfer that happens at the top of this big chamfer. So for the big chamfer, I use this puppy right here for the big chamfer. And then for the micro chamfer that happens at the bottom, I use this chamfer. And then for the micro chamfer that happens at the top, I use this chamfer. So let me explain it to you like this. Okay, so here's a cross section of the button, right? So this first big chamfer, it's a 45-degree angle, cuts it like that. And then the micro chamfer at the bottom is a 60-degree angle that cuts it more like that. And then on the top, it's a 30-degree angle, cuts it like that. So what you're left with is a shape that has a chamfer here, a big chamfer here, small chamfer here. So it gives it more of a smooth edge feeling, but to look at it, it looks rather blocky. So I really like it like this. It's the main difference between the Tranquilizer ER and the Tranquilizer ER Redux. There's a few other upgrades that are there. For example, the balance holes are an addition on the Redux, but the micro chamfers are the main things that make the Redux special, in my opinion. Let's get back to the machining. We're about to do the chamfers that I just explained to you. Start out with this big chamfer and go around the perimeter. We do this in a couple of passes. Speed it up here. Then I go around again and again until we get the right depth. And then I go around the opposite direction to ensure a smooth, glassy finish. Now we're going to do that micro chamfer on the bottom with this 60-degree chamfer here. So the next time you get Tranquilizer ER Redux, look at it closely and you can see those micro chamfers. Alright, now let's do the micro chamfer on the top with this 30-degree chamfer, which is actually a spot drill. But it's the perfect angle. I also put a micro chamfer around the inside ring. Okay, so after that we're doing our final facing, and sorry this is blurry. There it goes. So with this one I'm basically knocking off whatever kind of burrs that those chamfers have left behind. And I make sure I've machined it a little high so that I can come back and put a nice finish on it too. Let me speed this up. Okay, so after I machine the buttons, I will put them on a spinner and see how they look, and spin them and make sure I don't see any wobbling going on. Make sure that they're nice and round, that they spin correctly, and it can be kind of deceptive because we have this machine finish here. So it makes this top face look a little squirrely when it's spinning, but what I'm looking for is the profile of the buttons and the edges to make sure that everything is level, all the faces are parallel, because if they aren't, then there's no reason to move forward with them and clean them up and bead blast them, because they're garbage. So these look good, and hopefully the rest of these, which are over here, will machine correctly, and we can move all 8 of these spinners on to the next process. Okay, so that's it. That's it for the machining of the fidget spinner. We have all 8 on this batch ready to go to the next phase, and it is 10 a.m. here. I have been up all night machining, and so I wanted to get the rest of this footage shot for this video, get it posted before I take a much needed break. But I really appreciate you guys watching. I hope you had fun. I hope you learned some things. There is one more video left. We still have to clean these up, inspect them, get them assembled, well, before we get them assembled, get them ready to be bead blasted, get the bearings installed, and do a little final inspection on them. And if any of them are even the slightest bit out of balance, we're going to fine tune that balance. I'm going to show you how I do that. So I'm going to wrap this thing up, edit it, post it. One more video left, icing on the cake. This next video you're going to see how it all comes together, and a finished product of a beautiful copper Tranquilizer ER Redux that has been bead blasted, and how that looks. So until next time, I'm gonna get some sleep, and you take care of yourself. All right, bye-bye.